Okay, so how do you know if you have a permutation or a combination in a word problem? You have to ask yourself one question: does the order matter? Is there a difference in reward for the person who goes picked first and second, or first and third? Do they get a difference? If the order matters, if there is a difference, then it's a permutation. If the order doesn't matter, it's a combination. So we'll do a few of these to see how. Number 1, 6 students are running for president, vice president, and treasurer. The student with the greatest number of votes is president, then vice president, then treasurer. How many different outcomes are possible? Is there a difference between being president and being vice president or treasurer? Yes. So that means order matters. Yes. That means it's a permutation. It means 6p3. You can either put it as 6npr3 in your calculator. And if you do that, you should see that it will be 6 times 5 times 4, which is 120. I'll leave number 2 for you to do. And we'll do number 3. Baskin-Robbins offers 31 different flavors of ice cream. One of its items is a bowl consisting of 3 scoops, each a different flavor. How many bowls are possible? Now, assuming that they're all going into a bowl and not stacked on top of each other, does order matter, or does it just matter that you picked it? All that matters is that you picked it. So does order matter? No. So this is a combination. So you have 31, choose 3. And if you put that in your calculator, it's 44.95. Okay, let's go to the next page. Using combinations and the fundamental counting principle, or combinations and the permutations together. Sometimes you need to do 2 of these operations in one problem. For instance, within a group, you need some number of one type of an item and another number of another type of item. For example, there are 60 Democrats and 40 Republicans in the Senate. How many distinct 5-person committees can be formed if the committee must have 3 Democrats and 2 Republicans? So I have a certain number of ways to choose Democrats. Of 60, I need to choose 3. 60, choose 3. Of the 40 Republicans, I need to choose 2. So these will both give me a number. There are 34,220 ways to pick Democrats. And for 40, choose 2. 780 ways to choose Republicans. So since each of those is a separate piece, I have to multiply those 2 together to get the total number of possible outcomes. So if you ever wonder why nothing gets done in Washington, there are 26,691,600 different combinations of a 5-person committee if you need 3 Democrats and 2 Republicans. Yeah, that's impressive. We'll do number 2 as well. A zoo has 6 male bears and 7 female bears. 2 males and 3 females will be selected for an animal exchange program. How many different groups can be chosen? So we have male bears, we're choosing 2, 6 choose 2. Female bears, 7 choose 3. 6 choose 2 is 15. 7 choose 3 is 35. 15 times 35 is 525 groups. Okay, let's look at the next page. Now we're kind of just putting it all together and seeing what we can do. We'll do one of these. Decide which process needs to be used, then solve. Let's just do number 3. A manager chooses 3 people out of his staff of 8 to deliver a fridge. How many ways can the group be chosen? So this is Does order matter? No, you're either picked or you're not. So this is a combination. 8, choose 3. So you can either put 8 NCR3 into your calculator. And this is 56 groups. The rest of these are just more of ones we've already done. So I want to skip to something with probability. So most of these have multiple parts and they kind of trying to walk you through the problem. So remember, the definition of probability is the number of successes divided by total number of outcomes. So it's basically like doing 2 counting problems. So a comedy club has amateur night, 6 people want to tell a joke. There are 4 men and 2 women, but only 2 of them will get to tell their joke. What is the probability that the 2 chosen people are women? So how many total different groups of 2 can we make? 6 choose 2. There are 6 total people. 6 choose 2 is 15. How many groups of just women can we make? Well, there's only 2 women, and we'd have to pick both of them. So there's only 1 group. That's only if we have Anne and Emma, the only ones. So what is the probability of picking both women? It's simply 1 over 15. If you get these problems in the homework, they're trying to lead you to the right answer. We'll skip the probability that both are men. That one's not too bad. So let's skip to the next page and look at part C. What is the probability it's 1 man and 1 woman? The bottom is always going to be the same. Still 6 choose 2, which is 15. But now for the top, I have 1 man and 1 woman. So out of the 4 men, I need to pick 1. Out of the 2 women, I need to pick 1. This is 4 times 2, which is 8. So the probability is 8 out of 15. That's just a way to think about this. We'll skip the next problem and go to the next page and do one. A committee of 5 people is to be formed from 6 lawyers and 7 teachers. Find the probability that all are lawyers. So this is all in one now. The denominator is there are 13 people, and we're picking 5. There are 6 lawyers. We have to pick all 5. This is 6 over, what is 13? Choose 5. 1287, which is not a great probability. 0.005 roughly. None are lawyers means all are teachers. So 7 choose 5 over 13 choose 5, which is 21 over 1287. Still not the greatest odds. 0.016, 1 lawyer and 4 teachers. So in our numerator, 1 lawyer, we have 6 to choose from. We're choosing 1. Out of the 7 teachers, we're choosing 4 over the same denominator. So now this is 6 times 35 over 1287, which is 210 over 1287, which is much better as an odds. Still not great, but it is better. It's just 0.163. And any of the problems on the rest of the homework are like things you have seen before. So this is going to be the end of these notes.